Hi.
Good morning, good morning, good morning.
Guys scared me.
It started in about 1 minute. All right, here we go. Go ahead and get out your homework. And while you're getting out your homework, just one quick announcement. Hey, I still had 3 people that did not turn in their test. Even though I'm getting homework for some of you, for some reason you chose not to attach your test to the assignment marked Chapter 5 test. So Josh, Pierce, and Alexis, I still do not have your test. So over the weekend, I put in zeros for your grades. You can change this, but I need your test. You have until Wednesday. If by Wednesday you have not given me your test, it will remain a 0 forever. So please fix that. For everyone else, I do have your test and it's graded and it is in the grade book already. All right, let me share the screen. We'll get going here. Fun stuff today. Fun stuff today.
Excuse me, Mrs. Chartier.
Yes.
So I didn't join Friday's meeting because I was confused with the times, but I'm watching it right now. Like after this meeting, I'm going to finish watching it.
Sure.
But you guys are checking the homework. Is it okay if I join this meeting still?
Sure, I don't care. It's fine.
Okay. Thank you.
All right. Here we go. Let's see. It was 23 through 32. Any quick questions? Nope. Okay. Here we go. Now remember, I'm going to give you the least common denominator, or the least common multiple, and that will be the common denominator. If you chose another common denominator, then you didn't reduce your fractions. Then obviously, or I'm sorry, you shouldn't reduce your fraction because you'll get back to the original ones. But if you chose a different common denominator, as long as it's a common multiple, technically it's still a good answer. Number 23, if you chose 20 as your common denominator, which would be the least common multiple, that would be 15 20ths and 8 20ths. Number 24, 15 21st and 14 21st. Number 25, 15 18ths and 4 18ths. Number 26, 9 12ths and 2 12ths. Number 27, 21 24ths and 20 24ths. Number 28, 45 63rds and 56 63rds. Number 29, 10 44ths and 33 44ths. Number 30, 27 48ths and 14 48ths. Number 31, we had 3 of them, 27 36, 30 36, 14 36, and the last one, 32, 12 30ths, 21 30ths, and 8 30ths. And that was everything. Any questions? Okay, let's look at our schedule. We got a week, and then we're going on Thanksgiving break. Notice that we end on a chapter review. It is what it is. I wish we could have ended on a chapter test, but we couldn't. We'll do a review, and since we're going to take a week break, I'll do a second review on that Monday, and then we'll take chapter test on that Tuesday after Thanksgiving break. And fingers crossed, hopefully we were all physical in class come that Monday. Homework tonight, 6.3, 1 through 24 all, 1 through 24 all. And since it was brought up in class, just remember this Friday as well, we will do a normal Friday assembly schedule.
What time does your meeting start? So that way this time I could be there.
So I want you to notice, and you're going to figure this out yourself, I want you to notice that on every single assignment that I give, it has the times listed. So if you go to Friday's assignment, you will see the time that we meet is on the assignment itself. So make sure you're looking at that. And it's also the link for Zoom on every single assignment. The link never changes. Okay, here we go. Mixed numbers. Remember, we're doing 2 chapters on fractions. The first chapter is just basic fraction operations, not to include add, subtract, multiply, and divide. And the second, chapter 7 is on add, subtract, multiply, and divide fractions. So mixed numbers, 2 objectives. So many times when math teachers teach fractions, they always pull out our famous pizza, and we talk about pizza slices. So today I will use that as well. So let's say you have a pizza and you have 1 slice from this pizza, and we learned from our previous lessons that would be 1 slice out of the total number of slices, in this case 6 total slices, so 1/6. Nothing special going on there. You learn this in 3rd or 4th grade. All right, if we take 3 slices from this pizza, then that would be 3 out of 6 slices. The numerator always describes how many slices you have, and the denominator, the bottom number, always describes how many total slices that there are. All right, 5 slices would be 5 out of 6. All right, second thing is to remember that fractions also describe division. For instance, 3 slices, 3 out of 6. 3 out of 6, if you divide the numerator by the denominator, 3 divided by 6, you get 0.5. That's half the pizza. You could also reduce 3/6 and get 1/2, and that would describe half of the pizza. Okay, so that's background information. Let's say you have some friends over and you want to eat some pizza. So you got 1 pizza there, and we want to say every one of the girls gets 1 slice. So if every girl gets 1 slice, we are eating 4 out of the 6 slices of the pizza. All right, makes sense. We call that particular fraction, the fraction where the numerator is smaller than the denominator, a proper fraction. Please write this down in your notes. Proper fractions. Those are fractions that are defined as when the numerator, the top number, is smaller than the bottom number, the denominator. That's how we define proper fractions. Proper fraction, a fraction whose numerator is smaller than its denominator. Now you can probably guess where I'm going with this one. Everybody good? Okay.
No, I need a minute. No, I need a minute.
Okay. We've been dealing with the last 3 days on fractions. We've been dealing with proper fractions. That's all we've seen are proper fractions. Today we get to see the other types of fractions. There are two different ones.
I'm done.
Okay. So typically, obviously, in real life, no one is satisfied with 1 slice. So your friends now want to eat 2 slices, right? So if they eat 2 slices, well, there's 4 girls. That means they need to eat 8 slices of pizza. So 8 out of 6, and I think you can see a problem there. 8 out of 6, if there's only 1 pizza, we got problems. But before I talk about that problem, I just want to give you another definition. When the numerator is, and by the way, this is a perfectly fine fraction. When the numerator is bigger than the denominator, such as in this case, we call this, next definition, we call this an improper, an improper fraction. This is a fraction whose numerator is larger than the denominator, 8 over 6, or 8 divided by 6, or 8/6, or 8 6/10. This is a fraction where the top number is larger than the bottom number, or the numerator is larger than the denominator. Improper fraction. So proper, top number smaller. Improper, top number bigger. Proper fractions, improper fractions. Everybody good? Okay.
I need some more time.
If you haven't figured out how to use, take it off of mute, you just hold the space bar down, and then when you're done talking, let go. And then it goes from mute to unmute to mute.
Yeah, you can temporarily unmute if you just hold down the space bar and then when you lift it up.
Right, and then it goes immediately back to mute. Okay, moving on. So back to our problem, four girls, they want to eat 2 slices, 8 out of 6. Well, they can't do that if there's only 1 pizza and there's only 6 slices, right? So therefore they have to get another pizza. And this is what we're about to talk about, is this relationship right here. The fact that when you have an improper fraction, you're actually talking about more than a whole. All right, so 8/6, that's how many slices? We need 8 slices out of 6. Clearly, we can't get 8 slices when we only have 1 pizza if both pizzas are cut into 6 slices. Therefore, we need a second one. So the first pizza, we're going to take all of it. We're going to take the whole thing. And by whole thing, 6 divided by 6 is 1. And then we need 2 slices out of a second pizza. So we get a whole from 1, and we get 2/6 out of the other one. We push these 2 blue things together, and we make a new fraction called 1 2/6. And this is what we're going to be talking about next. So 1 2/6. Once again, we needed 8 out of 6 slices. You can't get that if you just have 1. You need a second one. Therefore, we take the whole first one, and we only take 2 slices out of the second one. You push 1 2/6 together to form our next fraction. Now, I do want to mathematically note that this does not mean 1 times 2/6. This means 1 plus 2/6. Okay. This is called a mixed number. Third definition, mixed number. A mixed number is a combination of a whole number, that's the 1, and a fraction. And our book calls it fraction. We're going to say proper fraction. So it's going to be a whole number and a proper fraction. You can have a combination of a whole number and an improper fraction, but we would ask you to reduce that fraction or change it back into another mixed number first. So even though the book doesn't say the word proper fraction, I'm going to say the word proper fraction. A mixed number is a whole number and a proper, and it can be larger than 1. You can have 7 2/6. That's a lot of pizzas. 7 pizzas. Actually, that's 8 pizzas total. 7 whole and part of an eighth. That's a good pizza party there. All right, mixed number. Combination of a whole number and a fraction. Everyone good?
Yes, sir.
Gavin is speaking for all of us. Okay. So I do want to contrast that with improper mix. So you don't have to write this part down. I'm just going to show you the 2 next to each other. So we are going to claim that 8/6 is literally the same as 1 2/6. So improper fraction on the left, mixed number on the right. This kind of begs the question, why do we need both of these, right? If 8/6 is literally the same as 1 2/6, the question is, why do we have 2 ways of saying exactly the same concept or the same numerical value? So it's a little bit easier to explain this in next chapter. You'll see it immediately, but I'll give you the explanation right now, and then repeat it when we get to the next chapter. So improper fraction, the numerator is larger than the denominator. Mixed number, that's a combination of a whole number and a proper fraction. So the reason we have both of these is it turns out that improper fractions are actually easier and sometimes necessary for most math operations. By math operations, I mean add, subtract, multiply, and divide. Not so much adding, but definitely for subtraction and multiplication and division. This year, you won't see why subtraction is a problem, but you will see that problem next year in pre-algebra. But for this year, we're going to mess around with both. Now, the question is, well, why, if improper fractions are better for math operations, why do we have mixed numbers? Because as human beings, it's easier to wrap our head around 5 1/8. I need 5 pizzas and a little bit of a 6th one than if you think about 41 over 8. Well, how many pizzas do I need to buy if I need 41 slices if all the pizzas are cut into 8 slices? You can kind of see there why mixed numbers are actually easier to wrap your head around in terms of, how many things are we talking about? If you had to calculate how much paint you needed to buy and you figured out it was 41 over 8 cans of paint, you don't go to the store and say, hey, give me 41 over 8 cans of paint. But if you say, hey, I need 5 1/8 cans of paint, you clearly got to buy 6 cans. But that's something that we as human beings can wrap our heads around. So that's why we have both improper fractions and mixed numbers. Okay, we're only going to do 2 games today. This could be a review for some of you. Hopefully this is not brand new, but some of you can forget this stuff from year to year. You won't forget this stuff by the time you get to high school, but yeah, up until 8th grade, we will review this. We review this every year after you learn it. All right, so we're going to be converting. We're going to be converting from improper to mixed numbers and from mixed numbers to improper fractions. That's the drill today. Now, some of you right now might be able to remember how to do this. Others of you might need a gentle reminder, and hopefully only a few of you, this is brand new. Now, remember, this class is being recorded, so if I go too fast or you're like, I need to see that again when you start doing your homework, by all means, remember I post the homework by 4 p.m. every day, so you can have the homework playing while you try to, or have the class playing while you try to do your homework. All right, so here we go. So to convert an improper fraction to a mixed number. Now, we'll write the steps down later, but I just want to show you a couple quick examples. So to convert an improper, remember an improper fraction is a fraction where the numerator is larger than the denominator. To convert an improper fraction to a mixed number, this is how it goes. We take the numerator, which is 41. We divide it literally by the denominator. Well, that's what the fraction mark means, division. Let's see, 2 goes into 41 20 times, right? And that's bottom in the top, the division. 2 goes into 41 20 times with a remainder of 1. You see how I did that? 2 goes into 41 20 times, remainder 1. Turns out that's all the information we need. We take that answer, 20 remainder 1, and we turn it into that mixed number. So let's see how we constructed that. 20 will be the whole number. Why? Because 2 goes into 41 20 whole times, and you got 1 left over. So 1 is what we need from that, if you want to go back to the pizza analogy there. 1 slice from that remaining pizza, and remember our pizza is divided into 2 slices. Every pizza is cut in half. Okay? And that's how it's done. All right, so 20 is the whole number, right, because 2 went into 41 20 whole times. 1 is your remainder, 1 goes in the top, the numerator, because we need 1 more slice out of that final pizza. So technically I need 21 pizzas, but I'm not going to eat all 21 pizzas. I need 1 slice from that remaining pizza, and all the pizzas are cut up into 2 equal slices. Okay, and that's where those numbers come from. Questions? Now, obviously, the hardest part of this process is this step right here, 41 divided by 2. Now, granted, I gave you a nice friendly one to start off with. Sometimes these aren't friendly. For instance, how many times does, 13 go into 41? So if this bottom number, the denominator, was 13, it's a bit more challenging. Scratch work is required. All right, so here we go. Here's another one. So it looks like I got things cut into 4 equal slices. I need 15 of them. So to write this improper fraction as a mixed number, I divide the top number by the bottom number. So the bottom number goes into the top, or top divided by bottom. 15 divided by 4, 15 divided by 4, 4, 8, 12, 16 is too much. So 4 goes into 15 3 times with something left over. So the leftover part is the part that you also need to do. So if I count by 4s, 4, 8, 12, that's 3 of them. I will subtract from 15 that number that I just got. 3 times 4 is 12. 15 minus 12 is 3. So that would be my remainder. My remainder would be 3. So to plug it all together in our final form, the mixed number, the whole number goes out front. The remainder is our new numerator. and our denominator will always be our original denominator. So 3 3/4 is the answer. Questions? All right, good. No questions. Once again, the hardest part is this right here, 15 divided by 4, to be able to do that. And then the second part is, well, you will have to do some subtraction. Now, some of you can do this whole thing in your heads. Others of you cannot. So there's no shame in doing some scratch work. All right, let's do one. Write this down on your paper. 14 thirds, or 14 3/10. 14 thirds. Step number 1, we need to divide the top by the bottom, or if you want to say the bottom into the top. Okay, so we need to do a little bit of scratch work. 3 into 14, or 14 divided by 3. Let's see, count by 3s. 3, 6, 9, 12. That's 4 of them to get to 12. So our whole number will be 4. Well, I said 3 times 4 is 12. So 14 minus 12, we're calculating a remainder here. 14 minus 12 is 3. So we get is 2. Sorry, that was bad math. 14 minus 12 is 2. That would give me a remainder of 2. And remember, to write this as a mixed number, this number out here, this whole number is our whole number of our mixed number. The remainder is our numerator, and the denominator is always our original denominator, 3. So 4 2/3, or 4 and 2 3/10. Questions? Okay, no questions. Yes, I'm giving you nice, easy, friendly ones tonight for homework. Some of them will be a bit more challenging than this, but the process doesn't change. Write this one down, 26 5/10. 26 fifths.
Can I solve?
Let's wait till we get to the green square. Let's see, 26 fifths, we got to divide the bottom into the top, or 26 divided by the bottom. So when we do that, let's see, see, 5, 10, 15, 20, 25, that went 5 times. So 5 evenly goes to 26 5 times. 5 times. Uh, 5 times 5 is 25, so it's 26 minus 25. That's a remainder of 1. So this is all we need in order to make this. 5 is our whole number. 1, the remainder, is always our numerator, and our denominator was our original denominator, 5. So we get 5 1/5, or 5 1/5, or 5 1 5/10. Either one is correct. Questions? Okay. There's a big but here, and the big but here is that, remember, we always have this rule that says that all fractions, whether they be improper, mixed numbers, or proper fractions, must be written in lowest terms. In other words, they have to be reduced. Okay? So here are 2 improper fractions that I want to convert into mixed numbers. Notice I got the same improper fraction for both examples. You'll see why here in a second. So let's follow the procedure we just did, 30 4/10, or 30/4. Let's see, 4 goes into 37 times. 7 times 4 is 28, with a remainder of a 2. So 30 divided by 4 is 7, with a remainder of 2, because 4 times 7 is 28. 30 minus 28 is 2. So this would be what? 7 2/4. And the problem is this, that 2/4 can be reduced. The greatest common factor between 2 and 4 is a 2. So if I divide top and bottom now by 2, it's all I'm doing is writing the fraction lowest terms. In other words, reducing the fraction. I get 7.5 as a final answer. So yes, you will be required to always reduce your fractions. Now it turns out, if you choose, you can reduce the fraction from the start. You have 2 choices. You can reduce the fraction at the end, or you can reduce the fraction at the very start. Some people like to reduce the fraction at the very start, and they think that it makes it easier because you're dealing with smaller numbers. Other people are like, I'm okay, I'll just wait to the end. And the true answer here is it doesn't matter. Whichever one you like to do will be perfectly fine. I'm kind of in the second boat. I would rather reduce from the start, and that way I deal with smaller numbers for the division. All right, so if I reduce from the start, 30 and 4, the GCF of 30 and 4 is still 2. So if I divide 30 and 4 both by 2, I get 15 over 2. So the difference is instead of dealing with a larger number, 30, and now I'm dealing with 15. Instead of dealing with a 4, I'm dealing with a 2. So the argument is that smaller numbers, the division's a little bit easier. I'll let you decide which one you like. 2 goes into 15 7 times. 7 times 2 is 14. 15 minus 14 is 1. So with a remainder of 1. So that would be 7 and 1. And here's the deal. We're not turning it into over 4 because we reduced it to a 2. So if there's an issue with the second one is that you need to remember that you now converted your denominator from 4 to 2. So the people that were like, well, I'll screw this up because I'll write it over 4 and get it wrong. Okay, then stick to the technique number 1. Questions on the 2 techniques? Okay, let's do one. All right, I want you to use both techniques just for one of them, and then I'll let you decide which one you like the best. All right, so the top one will reduce at the end, and the bottom one will reduce right at the very start. So on the top one, if we reduce at the end, let's see, 10 goes into 55 5 times. 5 times 10 is 50. 55 minus 50 would be 5. So we get 5, remainder 5. So that would be 5 and 5 tenths. Now we look at this fraction 5 tenths and make sure that it can't be reduced. Oh, it can be reduced. The GCF of 5 and 10 is 5. 5 goes into both 5 and 10. So we divide top and bottom by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. So we get 5.5. Okay. Second one, technique number 2 is we reduce immediately. 55 and 10, the GCF is 5. Notice in both cases the GCF was exactly the same. Some of you may say, well, this would be harder for me because I would have to figure out what the GCF is of larger numbers. I agree. Okay, 55 and 10, so we're going to divide top and bottom by 5. That's 55 divided by 5 is 11. And 10 divided by 5 is 2. 2 goes into 11. Let's see, 2 goes into 2, 4, 6, 8, 10, 5 times. 11 divided by 2 is 5. Notice I got my 5. 2 times 5 is 10. 11 minus 10 is 1. So we get 5 and 1 over 2. There are your 2 techniques. Pick and choose whichever one you like. Perfectly fine. Gavin, which one did you like? Gavin,
Yes,
which one did you like?
the first one.
I think that some people gravitate towards the first one only because of this GCF part right here. Typically at the very end, it's easier to figure out the GCF. Sometimes at the start, it's harder to find. Okay, you get to make your choice which one you like. All right, all by yourself, no help from me. Do these 2, please. These are 2 different ones. You can use either technique, one of them can be reduced, one of them can't be reduced. I'll give you about a 30-second head start, then I'll walk you through it. All right, first one, let's see. I can divide 26 by 6, or 6 into 26, 6, 12, 18, 24, 30. Okay, so it goes 4 times. 4 times 6 is 24. 26 minus 24 is 2. So we get 4 and remainder 2. 4 and 2/6. Let's look at 2/6. What goes into 2 and 6? A 2. So divide top and bottom by 2, the GCF, and we get 4 and 1/3. 4 and 1/3. Check to see if you got 4 and 1/3. If you did, you got this down. Second one, 22 over 9. So let's see, 22 divided by 9, 9, 18. Oh, it only goes 2 times, 2 times. Oh, wait, why did I write 3? Well, there's a math mistake. Let's see, 9 times 2, it's not a 3. 9 times 2 is 18. 22 minus 18 is 4, so we get 3 and 4/9. 3 and 4/9. Or it's 2 and 4/9. Ugh, let me change that. The 3 didn't change. Why did the 3 not change? There we go. All right, questions on these two. Questions on these two. Cool. All right, well, let's switch. Get it? All right, so now we're going to convert from a mixed number to an improper fraction. Mixed number to an improper fraction. Most math teachers have their own little way of teaching this. I'll show you my technique. If you learned another technique and it works great, stick with it. You don't have to learn my technique. Here's my technique. I call it the circle technique. To convert a mixed number to an improper fraction, we make a big circle, and I always go clockwise. You will start at the 6 o'clock position, that's straight down. You will start with this 5 right here. So what we'll do is we'll start with the denominator and we multiply. We multiply the denominator by the whole number. So we do 5 times 5, 5 times 5.
25.
Right? Then we add, that's the third step,
2.
we add the numerator. 25 plus 2 is 27. That becomes our new numerator. And we rewrite, I continue this circle all the way back to the old denominator, and that becomes the new denominator. So I call this the circle method, and I always go clockwise. Once again, it's denominator times whole number plus numerator all over denominator. So for those of you who like steps, here are your steps. You start with the denominator. You multiply, you can write by the whole number. You add the numerator, and you can say that becomes the new numerator. And then you rewrite the denominator. Hopefully this is not new to you. Hopefully this is just a review or a refreshment of material that you already learned before. Start with the denominator. You multiply by the whole number. Add the numerator all over the old denominator.
It's 56.
All right, everybody good? All right, here we go. Once again, the steps are clockwise. We start with the denominator. We multiply the denominator by the whole number. So 8 times 1 is 8. Plus the numerator, 8 times 1 is 8, plus 3 is 11. That becomes my new numerator. All over 8. All over 8. Big circle we're making. Everybody good? All right, let's do one. All right, write this one down. Beat me to it if you can. All right, for those who need help, we start with the denominator. We go clockwise. The denominator is 6, and then we multiply. 6 times the whole number. In other words, 6 times 2 is 12. Now we add the 5 to our product. 6 times 2 is 12, plus 5 is 17. 17 is our new numerator, all over 6. You can do a check step to see if you got this right. 6 goes into 17 2 times. 6 times 2 is 12. 17 minus 12 is 5. So you can always do a check step to make sure you do, in fact, get back to 2 and 5/6. And in this case, we did. Questions? Okay. Let's see, one more time. So we follow the steps. We start with the denominator and we go clockwise. We multiply. 11 times 9 is 99. Okay, the numbers can get large at times. Don't panic. Do some scratch work if necessary. You don't always have to be able to do these in your head. 11 times 9 is 99. We add the 3 to that. 99 plus 3 is 102. All over 11. Not bad.
That's a big number.
It is a big number, and this is why a lot of people are scared of improper fractions, because a lot of times they are very large numbers. We will learn. We will learn next chapter that you can only multiply and divide with improper fractions. You can't multiply or divide with mixed numbers, and that is why it is a requirement that you actually do math with improper fractions.
If it's past 20, I can't count to it.
I'm pretty sure you can count past 20.
I can do finger and toes math. That's it.
Borrow your brothers or your sisters' fingers or toes. All right, here we go. 4 and 7/9. Write that down. Beat me to the answer. Do not yell out the answer. All right, let's see. Process is we go clockwise. Denominator times the whole number. 9 times 4 is 36. Gavin's in problem because he's past 20. 9 times 4 is 36 plus 7. There's no harm in doing some scratch work. If you have to off to the side, say 9 times 4 is 36, and 36 plus 7, let's see, what's that? 13, carry your 1. That gives me 4, and you get to 43. There is nothing wrong with that. Okay, nothing wrong with doing some scratch work. All over 9. Questions? Okay. Do these two, please, all by your lonesome. I'll give you about a 30-second head start, and I'll go. All right, see, first one, clockwise. 5 times 8 is 40. 40 plus 3 is 43. We get 43 over 5. Second one, 3 times 12, 12, 24, 36. 3 times 12 is 36, plus 2 is 38. So we get 38 over 3. And we're done. Confident? Okay. Any final questions from anyone? Today was a rather quick class. Nothing too challenging. It was just a refresher material. Take a quick look at your homework. It is simply converting. There's nothing, no surprises here. A few of them have very large numbers. I'm looking at questions 23. That's a pretty darn big number there. 24 is even larger. Even larger. All right, so the homework tonight is exactly what we just did right there, converting improper fractions to mixed numbers and then mixed numbers to improper fractions. If you did today's class, fine. You will run into no problems except that the numbers are larger. Just last reminder is that all fractions must be fully reduced, fully reduced. So reduce all your fractions. Any final questions?
No.
Cool. We'll stop
Here,
class.
here's my sister. There's my sister.
Ask her to
You
borrow
have
her
sister.
fingers and toes.
She only has 4.
Well, then I guess you can count to 24 now, can't you?
28, but still.
Aww.
All right. You guys have a wonderful day, and I'll catch you guys on Tuesday. See you later.
Bye.
Bye.